Everyone, welcome back. My name is John Ibini Ode. Okay, so today I will show you how to do basic static and dynamic analysis on Linux binaries, and we are going to be working with a simple demo program using only native Linux tools like objdump, strings, and GDB. Okay, so this is beginner friendly. So let's jump right in. Okay, so I have two files here which I've created for this particular demonstration. So I have a C program here which we're going to compile. And if you take a look at this, you see that it writes a file redemo.txt into this temporary directory on the Linux system, and then it prints. Now, if this becomes successful, here we have it here, this condition, then it prints what reverse engineering demo file created successfully, and then it prints demo program executed, and then it makes a get request to this endpoint. All right. And this endpoint is going to be served by this server program here, written in Python. Okay. So let's get to work. So first of all, what we are going to do here is we are going to compile the program redemo.c. Okay, like this. Now this dash G here means I want to add debugging symbols to the final executable so that when we are debugging it, we can have symbols to make our reverse engineering process or activity easier. Okay. So what we are going to do next is we are going to make use of a tool known as file. So file is a Linux tool that we can use to check out the file type of a particular executable or of a particular file. All right. So let's do this demo. Now we see that this demo here, this final executable is a Linux file. Why? Because we have it here as what? Executable linkable format, and this is built for 64-bit systems. And we have here least significant bit position independent executable. All right, so it means that this binary is not dependent on what positions. Okay, so that's why we have this pi here, and then we have other things here like you see it was compiled with debug info. Remember I added dash G here. Okay, so and the executable is not stripped. Like I said, not stripped means we have symbols that will make our reverse engineering process easier. Okay, so these symbols are just like hint or a roadmap that tells us where in the executable a particular section is located. But if it is stripped, you won't find any symbol. Like you won't find much symbol to work with, and it can make your reverse engineering activity very, very hard. Okay, so let's now try to use readf. So readf is a Linux tool which we can use to read Linux F files. Okay, so F stands for executable and linkable format. Okay, so I'm just going to let's read the header. Okay, the header of the file. So hit enter, and one of the most important thing that you can focus on is the entry point address. Okay, here we have it as 0x1090. So this is the entry point address of this executable program in memory. Okay, so you know that whenever you try to run a program, what happens is that the operating system allocates what to call an interpreter, like a linker. Okay, so like, yeah, just like a linker to the executable. And after setting the environment, like assigning the virtual memory addresses to the program, what the linker or the interpreter does is to look for the entry point address and then transfer control to that address. All right. So we have a whole lot of information here. And now this magic value here represent an F file. So every Linux F files, they start with this magic value 7F. Okay. So whenever you see 7F in any binary, just know that we are working with what? An F file, executable linkable file format. Okay, so the next thing we're going to do is we're going to diassemble it. We're going to see the diassembly of the executable. So I'm going to make use of objdump here. Objdump. Let's use the Intel syntax. Okay, because objdump is just like a tool that shows us information about object files and executables. Okay, so we are going to what is that? Re demo. Okay, and hit enter. So we have the assembly here. So one of the most important things that you can focus on most of the time is the entry point, the main function. Okay, so main is the entry point of every C program or C++ program. So from here, you can start from here and work your way up, because inside main you see the functions that will be called, that the program will make use of. Okay, so it just gives you that idea or that hint where to start your analysis from. All right, so we have here that where is it? Okay, we have some function calls here, right? We f open and we have f write. So these are system calls, not function calls. Okay, so system calls is just a way of a program requesting permission from the operating system to carry out a particular task. For example, if your program wants to read a file, write to a file, or open a file, it carries out what system call behind the scene. Okay, so we also have a system call here. All right, so now let's now look at strings. So strings is a tool which we use to extract printable characters like names, understand, like anything you can read, all right, from an executable. So we're going to use strings, re demo, hit enter. So you can see the strings present in this particular file, this executable. Okay, so let's go through it and see what we're going to find. Now we have redemo.c. This is the name of the executable, that is the source code where it was compiled from. We have here as what, redemo.c. And now let's see what we're going to find again. Let's move up. Okay, so over here we have call. You can see the call here. So this tells us that this particular executable makes an internet call, like it tries to access the internet. Okay, so over here I have the endpoint ping. So it tries to access this ping here, making use of the HTTP GET request. All right, then we have that. Okay, we have a redemo.txt, which means this writes a file known as redemo.txt to this directory here. I think when we assembled this data, I think we saw something like fopen. So that should be what it makes use of, that system call. That should be what it makes use of to write or open this file or even read this file to this location tmp. So let's see where I found that. I'm coming. I'm just going to increase this, clear the screen, and then run this again. So objdump -d-m intel re demo. Okay, so let's see. Yep, I have it here. So I think this is a particular point where it opens this file either for reading or for writing. Now if we take a look at the fopen function of C, we see that it has two parameters, file name, and we have the mode. So the mode there represents, do you want to read the file, do you want to write to the file, or do you want to append to the file? Then file name here is the name of the file you want to write. Okay, so let's since we have it from this file, where is it, file redemo.c, sorry, demo. Since we have it that this is an f file. Okay, so since it's an F file and it's not stripped, which means it is what, a 64-bit, it is built for 64-bit systems, and I guess it makes use of the how do they call it, the calling conversion, the 64-bit system calling conversion. Let me show you that calling convention for 64 bits. Okay, so you can see we have it here that this is a system VM-D64 calling convention. Okay, so now how does this work? Now a calling convention is just a way whereby the caller passes like a format where the caller of a function passes the argument to a callee function. Okay, so if I have something like this, let me just open a new file here. So now let me show you the calling convention of 64-bit system. So the first six parameters or arguments are passed into the RDI registers. Remember, 64-bit system makes use of what, RDI, okay? While 32-bit systems make use of EDI, okay? This for assembly like if you're not conversant with assembly language, okay, so this might sound like magic to you, but don't worry. So RDI, we have RSI, we have RDX, I think RCS again, and then we have let's see, RDI, RSI. The first parameter goes here. So the first argument goes here. Second, we have third, we have fourth, and then we have R8, and then we have R9. Okay. Then from parameter 7 and above, these are what pushed onto the stack. Okay, so these are pushed onto the stack. Okay, so if you take a look at what we have here, I'm coming, let me run objdump-d. We want Intel syntax, okay, not the gas syntax. All right, so dash slash re demo, so hit enter. So if you find out here, we see that fopen, like we said, fopen makes use of what it makes use of, has two parameters, file name and then the mode. So based on the calling convention I showed here, you would agree with me that the first parameter here is RDI and then RSI. So which means the file name here is what, RDI, while the mode is RSI. So if you come to this obj dump, we find out that where we have this fopen being called here by the procedure, this is located at the procedure linkage table. So you can read about that, okay? So I don't want to go deep into this PLT table, okay? So we have it here that the RSI here, the value of the RSI is gotten from array X, and the value of array X is gotten from this memory address here, or this memory location, and we use the load effective address command to load the content of this address into racks, which is now what passed into RSI. Now that is the mode, and like I said, it could be the read or write or the append to file mode. Then for the RDI, which is the first parameter, we have that the value, which is the file name, is located at this memory location, and then it is loaded into racks, and then racks now passes into what, RDI. Then fopen is now called with the appropriate parameters or argument. Okay, all right, so that is how to perform analysis, static analysis of an executable using these tools. Okay, so now what do we now do now? Let's go into the dynamic analysis, and for the dynamic analysis, I'm going to be making use of strace. Okay, so since this is strictly based on Linux system and we are not making use of Windows system, I'm going to show you how to use Procmon and other analysis tool for Windows system later on, because currently I don't have the Windows virtual machine installed on my VMware. Okay, so let's move into dynamic analysis. So for dynamic analysis, let me just clear the screen, and I think I should clear this and also exit from here. So for dynamic analysis, I'm going to make use of strace. So strace stands for system trace. So it's used for extracting or getting information about the system calls made by a program. Okay, so now since this program, the executable program, okay, since it makes a call to the internet, like it uses this to call to carry out a get request to this endpoint here. Okay, so what we are going to do now is we are going to make sure that we have our server running. So I'm just going to Control Shift R to split the screen again, and let's run the server. Okay, Python 3. Let's run this re server.py. Okay, so it's currently running. So I'm just going to, first of all, let's run this and see. Let's run the program first before we do that. Re demo, hit enter. All right, so we see demo program executed, and we got what, received get ping. Let's run that again. All right, so now, like I said, static analysis is just a way of analyzing an executable while you are not running it, or while it is not what, in execution. But dynamic analysis, you work with program while it is running. Okay, so if you see, this is just benign examples of programs I'm making use of. Now if you are working with malware, all right, you need to set up your sandbox environment properly so that your main system doesn't get affected. Okay, so that everything you do is just within the virtual environment or the sandbox environment. So okay, so what we're going to do now is we're going to use strace here. and we're going to capture the file and network system call. Okay, so we have e, then trace is equals to file and network. So we're going to store the result to, let's call this re demo dynamic, okay, dot log. All right, and what else again? I'm just thinking of what to do. Okay, now let's see, hit the enter key. Okay, so strace must have, okay, sorry, I didn't give uh the executable. All right, so we have a demo program executed. Now if you do ls, we have the log here. Okay, so let's display the log and see. Let's re, sorry, mcls, what's the name again? Okay, let's re demo dyn dot log, and let's see. Okay, so I'm just going to shift this to the right hand side. Now let's see the system calls, the file. Remember, we are just working. We we looked for the, like, we want to just extrapolate the file and network system calls made by this particular program. Okay, so let's read it. All right, so this we have here the execv function in um in the program. Like, the execv function is being called by the Linux environment here to execute this program, redemo. Okay, then we have since we're looking for the file and network, okay, we have that it created a file to this directory. Now let's go over to the directory and see what we have. So I'm just going to open a new window here, new window, cd temp, okay, ls, boom, we have it here, redemo.txt. That's correct. So let's go back again and see. Remember, we are capturing only the file system calls made by this command. So they made by this program. Okay, then we have, what other things do we have? Okay, this is the directory. All right, hit enter. Now all these system calls we have here are file and network system calls. Okay, so let's look at the network system calls here. We've just been seeing the file system calls, so let's look at the network. Okay, all right, so we have network system calls here, sec socket option with this arguments here given to it. Okay, now that calls the network capability. That is, it's just a way of accessing this sec option here is a network system call. All right, telling the kernel to give permission for the program to have access to the internet, okay, or to make use of this call here to access this endpoint. All right, so let's go back there and see what we've got again. So all right, so this is just where it just sets up the or what it needs to carry out the internet connection. Okay, so let's move down. Then we have the get request here, get ping to this endpoint here, right? This is the resource or the endpoint that this particular program or executable is trying to get. Okay, so we have the host. Now let's move down. Okay, so receive from. Now this receive from is a function. Okay, it's a network function. Like, if you know much about C networking, you see that it's a function. Even on Python program also. So whereby it's just a way of receiving data from the destination or the target site or target server. Okay, receive from. Okay, so we have a response here from the server, and that was the reason we got ping here. So the program sent a request for the ping endpoint to the server, and the server responded with what, 200. Okay, so that is what we have here, the 200, the HTTP 200 status code. Where is that again? Where did I see that? Where is the 200 status code? 127. Okay, receive from. Okay, yeah, this is it, 200. Okay, so let's move. Now it's received null from the server. Okay, then so that is the end. So it received nothing from the server, so the server doesn't send any response back. So if you check here, we have here return. You just, where is it? Received. It received this, where it received the get request, and then it sends what, 200 response, and then this is it's writes, how do they call it, punk. Okay, then what do we have here again? Log message return, blah blah blah. So let's see what we have here. I'm going to queue and then let's run this again. Re demo, hit enter. So demo program executed. We got what? A ping. Okay, so that is all about this. Now you can decide to also capture this using Wireshark, so or TCP dump, okay? But TCP dump is just command line. So let me just start up the Wireshark and show you also. So Wireshark is also something you can use for your analysis also, okay? Like for your dynamic analysis to capture the network traffic of the machine, okay? Sorry, of the program, right? So how it accesses the internet and what resource it accesses in the internet. So I'm just going to capture on my ETA0 interface, and let's run this again. So the slash re demo, hit enter. Now let's see what we have here. Does not start capturing yet. I'm coming. Sorry, yeah. That should be. I'm coming. Let me stop recording. Remember, we are making use of the loopback interface. Okay, so we're going to make use of the loopback here. So I'm just going to select the loopback interface and let's run this. All right, so we now have results here. So I'll stop capturing, pressing this red square there. All right, so we have the request here, get ping request by the program. You can see the HTTP request body. So the HTTP request body, empty, and we have the request line here to the ping endpoint, and then we have the response here from the server. Okay, 200. Okay, all right. So now let's check the data and see what you have there. So let's so that's just how to carry out dynamic and static analysis of program. Okay, so this is just beginner basics. All right, so let's try to make use of GDB right now. So GDB is a debugger, GNU debugger that you can use to analyze a particular program while it is in execution. Okay, so I'm just going to clear screen, and over here I'm going to stop this server. Oh nope, let me just leave it running. Sorry, I'm going to open a new window to leave it running. So sorry, a new tab. Okay, so let's open a new tab, and I'm just going to python 3 re server.py. So let's make use of GDB right now. So gdb dot slash re demo, hit enter. So the command you need to know when working with GDB, we have the break command, we have the step command, which you can use to step into functions, and also we have the next command, which you can use to step over functions. Okay, so I have it here. So let's run this. Okay, so I'm just going to let's break at main. Remember I told you that main is the entry point of every C program. So we are currently there. So we'll just run and let's see. All right, so starting the program, and okay, so we're currently at what the main function right now. You can see these pointer here. Okay, so we have the source code also of the main function here. Remember, the symbols are not stripped. Okay, and we see the fopen where the file is opened and written to this temp directory here. Then over here we have the assembly here. Okay, now this is the assembly, and we have W here. Remember the, how do they call it? We use objdump. I showed you the result of the objdump where I explained to you the parameters taken by this fopen function here. All right. So we have the RSI here, which is the RDI. Remember this if open takes two parameters. Okay, the first one is the file name, and then the second one is the mode. All right, so the file name is stored in RDI, while the mode is stored in RSI. Okay, so we have the mode here as well, writable. Okay, we have it here. This is where it's stored W. Okay, you can see it here W, and let's check the source code for that. See it here. Okay, so W here is stored in this address, and then it is loaded into racks, and then it is moved from racks into RSI. All right, so the file name is stored here. Okay, you can see it here, redemo.txt, which is what we want to write into. into this directory here, tmp. Okay, so it is loaded into rags, and then rags loads it, and then from rags it is moved into rdi, and then the fopen function is called. So we are currently there. Okay, so you can see a whole lot of the registers here. Now, at this point, RBS is pointing to the RE demo, which is the executable we are currently running. And let's continue. So we do next. All right. So next, currently we are here. Okay, where is that? Yeah, we are here right now. Okay, here where the file is being opened, and then if you keep on doing next, okay, we move forward. You can see this pointer here. We are now at the if statement, the condition. Then next, next. All right, F close. So we are currently here. So let's move next, next into the system call function. All right, so let's see our server here. So no requests shown on our server yet. Okay, so we're currently at this particular place. Now this is where the program, the pointer is right now. Okay, so this is where we have our program counter. Okay, so this is where it is. So that's where the program counter is. So if I should do next, now let's check our server here. Okay, you can see the response right now to this endpoint ping. Okay, let's go back to our GDB, and I think it has stopped executing. All right, the execution has stopped because that is where after this particular system call we have the return 0 here. Okay, so let's see what we have here. Thread debugging, blah. So all this information here are just so long as we have it executed successfully. All this information here, error and resetting breakpoint, no symbol is loaded. So just forget about these error messages shown here. So that's just the basic way of making use of GDB. All right. So I'm going to be making more advanced video on how to make use of GDB. Okay. So just know that this particular video or demonstration is all about it's just beginner friendly. Okay. Just to show you the static and dynamic analysis. All right. So that's all about it. Thank you for staying with me up to this time, and see you in the next video which I will be making on my channel. So please, if you know you have not subscribed, please do well to hit the subscribe button, and don't forget to turn on the notification bell so I don't get to miss any of my videos. Thank you, and bye. See you next time.